Okay, so next chapter is your hydraulic jump. Okay, I think we have already discussed the general thing of hydraulic jump. Okay, but you see, the hydraulic jump, we sometimes create hydraulic jump or sometimes it naturally occur. Okay, so these are some examples of occurrence in the field of hydraulic jump. Suppose in first case, if you see in the first figure, there is a sluice gate. Okay, once you open the sluice gate, there is it's reduced the cross section, so the velocity is very high. Once it goes out and then it caused a whole space, and then your depth of flow directly increases, and because of this sudden increase of depth of flow, that jump occurs. Okay, so this is called hydraulic jump, or you can also say that it's a rapidly varied flow. Okay, gradually varied flow is here in section, sorry, uh, second figure. You can see whenever you construct a dam in upstream, or here you can see the flow is gradually increasing. Okay, the flow you can see is gradually increasing, and afterwards it's overflow. Okay, here it is gradually varied flow. Okay, and the downstream section, when it falls from a very high head, here it strikes and then water jumps. Okay, so we will be two depth of flow, one is y1 and one is y2. Okay, y1 is depth of flow before jump, y2 is depth of flow after jump. These two are called sequence jump. Okay, sorry, sequence depth. One is before jump, one is after jump. As your depth of flow is rapidly changes, or all of a sudden it changes, that is why it is called rapidly varied flow, or you can say it's a hydraulic jump. Okay, so you can draw these figures. These are some field conditions where you can find hydraulic jump. One is when you use sluice gate. Another one, this is very common, it's for a dam. When you construct a dam or any obstruction, you can see this hydraulic jump at the downstream end. Okay, then suppose the channel slope is steep, and after that, after some length, this channel slope changes to mild, then there is a jump occurs. Okay, another one, if we have any underwater obstruction which is submerged. Okay, so this dam and this thing are two different. One is submerged, so the level of water coming here, and because of this submerged, there is some decrease in water level, and then again it increases. Okay, here also, if you have a cross section like this, then again also you can observe some jump. Okay, in the narrow section. This is what we are discussing about canal fall. Okay, when depth of flow here is coming, and then because of this canal fall, your depth of flow reduces. Okay, and then your canal bed changes, so because of this again it strikes here, and there will be some jump here at the downstream end. Okay, so these are the figures are very commonly you can see in your native place, and you can observe hydraulic jump. Okay, so there are different types of jump also. Some are strong jump, some are weak jump, depending on the criteria. Okay, so you can draw these diagrams. Over. So if we move on to the next topic is your use of hydraulic jump. Okay. So there are various use. We will discuss only the common and most important. Okay. So next topic you write the use of hydraulic jump. Okay. So first one you write hydraulic jump used as energy dissipator below canal fall where over fall spillways in silting basin. Okay. So that to minimize the energy. Okay. Or to prevent the scouring when you see in constructing dam or large structure when there is a spillway or overflow of water at the downstream end, it has a very high impact because the water flows falls from a very high head. Okay, so because of that there should be some scouring and which affects the structure. Okay, so that is why sometimes we use hydraulic jump as an energy dissipator or to minimize the energy for a large extent. Okay. In second case, we also use hydraulic jump to increase the weight of the apron. Apron is nothing but when you construct a structure in the downstream end, we put one concrete structure. This is called apron. Okay. If you go for a design of hydraulic structure, there you can study those things in details. Okay, by designing apron and all you have to consider the weight of the apron with against the uplift pressure. Okay, so those uplift pressure if it is a greater than this apron, then your structure will fail or overturn. Okay, so those things it's not in this subject, it's not here in syllabus, but we use hydraulic jump to increase the weight of the apron because the water is falling in that particular apron, and because of this there is a high impact with that apron and which increases the weight, and thus it offers resistance to the uplift force under hydraulic structure by raising the water depth in the apron. Okay, so this is our second point. And third case, in irrigation purpose, sometimes we use hydraulic jump to mix chemicals, okay, to purify the water if it contains some impurities. Okay, so this is the third point: to mix chemical used for water purification in water plant or in irrigation. Also, if you want to distribute some this chemicals, or you can say, so then we mix it with water by using hydraulic jump. We mix properly. Then number four, is to raise water level for irrigation and other distribution works. Okay, if we can create a hydraulic jump, then our flow of water increases to a greater height. Okay, before it is y1, and after that it increased to y2 value. Okay, so after that, when it increases, we can easily divert the flow for irrigation or other works. Okay, so we can easily distribute. So in those case also, we sometimes use hydraulic jump to divert the water for irrigation. Okay, the last one you write number 5, to increase the discharge of a fluids by holding back tailwater. Over, there are a lot more uses of hydraulic jump, but these 5 are the most important. So we are discussing this. Okay. So others, there are lots of uses. Those are not that much relevant, or you can say those are not frequently used. Okay. So that out of all this, you can see here it's written, out of all this, your energy dissipation below hydraulic structure is most important. Okay. Okay. So now we derive a relationship between yn and y2. Okay. Suppose this is your hydraulic jump. Okay. Here we have y1 before the jump. Okay. And after the jump, the depth of flow is y2. So we are going to find one relationship between this y1 and y2. Okay. So for rectangular channel, so you can write down this jump analysis in rectangular channel. This is very important when you go for a competitive exam. There you can find some questions related to this y and y2. Okay, where y1 is given, you need to find out y2 value, or y2 is given, you need to find out the y1 value. Okay, so you write down the jump analysis in rectangular channel. Okay, then you write down this expression. Write down the expression. I think you are familiar with this equation. This we have already derived in chapter 1 or 2. Okay, just you can write down one line. This came from momentum equation. Okay, this came from momentum equation. Okay, and derivation of this is already there in this. Okay, I am going to share this all the files today. Okay, After the class I'm going to share all the files. You can also find out this derivation, okay? But whenever in the exam you are asked to derive, so you do not have to derive this expression again. You can directly use this expression and then you go for the derivation of yn and y2 value, or to derive the relation between yn and y2 value. Okay, so you directly write down this expression. Okay, so now here area 1. Okay, so for rectangular channel area is b into y, so it is a1, so we have written b into y1. Okay, and xor bar is nothing but your y1 by 2. Okay, then q square is already there. G, in place of a1 again we have written b into y1. Okay, is equal to a2 is again b into y2, x2 bar is y2 divided by 2 for rectangular channel. Okay, plus q divided by g, again a2 in place of a2 we have written b into y2. Okay, that area of a rectangular channel is b into y. Okay, then you move on to the next. Okay, then we are dividing the whole equation by 2 by b. Okay, so here if we divide 2 by b, this first term, so this 2 and 2 will be cancelled out. If you divide this 2 by b, okay, so it's not dividing, you can write it's multiplying. Okay, there is a small mistake here, you can write multiplying. Okay, it's not divide, it's not dividing, it's multiplying 2 by b. Okay, if you multiply 2 by b, this b and this b will cancel out, this 2 and this 2 will cancel out. What will be left out is y1 square. Okay, the next term also we have to multiply it by 2 by b. Okay, so that is why twice q square divided by gb square. Okay, here is already 1b and here we have already 1b, so it will be b square y1. Similarly here also y2 square plus twice q square gb square y2. Okay, now what we did, we bring all the y value in left hand side and other terms in right hand side. Okay, so that is why y2 square, if you bring this y1 square in the right hand side, it will be minus y1 square. Okay, and here also we have already 2q square gb square, and we bring this to here, so it's minus. Okay, so you can see in this two equation term we have twice common, q square is also common, g and b square is also common. So what is left out is 1 by y1 minus 1 by y2. Okay, so here a square minus b square, you can write a plus b, a minus b. Okay, simple mathematics. So here also we are doing the same thing, a plus b multiplied by a minus b in place of a square minus b square. Okay, so this will be remains same as it is. Here also you take LCM y1 y2, so it will be y2 minus 1. It's very simple mathematics. Okay. Okay. So this y2 minus y1 and y2 minus y1 will cancel out. We have y1 y2. It will be cross multiplied. Then it will be y1 y2, and this is already there, y2 plus y1. Okay. So q square by b square. We know small q is nothing but distance per unit width. Okay. So that is why q square by b square we can write q square, small q square. So twice q square divided by g. Okay. Then we'll be having y1 y2 square plus y1 square y2 minus twice q square z is equal to 0. Yes, so here in quadratic equation you can directly take this equation minus b plus minus a square minus 4ac by twice a. Okay, so this equation you can do. Okay, and if you again further solve, you will get this expression. So this is the final expression. Okay, in first case they have neglected the minus term. Okay, they have taken the addition one. Okay, so you work this thing in home. Okay, and if you see you are getting the same equation or not, but you have to remember this equation: y2 divided by y1 is equal to half. Okay, half minus 1 plus root over 1 plus 8 fr 1 square. Y2 divided by y1 is equal to half minus 1. Y2 divided by y1 is equal to half minus 1 plus root over f 1 plus 8 fr1 square. So here, if your y1 is in denominator, then here will be fr1. Okay. If y2 is the denominator, then it will be fr2. Okay. Always remember the other things are same. Okay. One is your y2 divided by y1. If you write y2 divided by y1, then you will be having fr1 square. That is half minus 1 plus root over 1 plus 8 fr1 square. Or if you write y1 by y2, it's half minus 1 plus root over 1 plus 8 fr2 square. So these are the two relation between the y1 and y2 value. If in the numerator we have y2, so if it is y2, then there will be fr2 will be there. Okay. So fr1 and fr2 is nothing but fr1 is the Froude number for y1 value, or you can say before the jump. Fr2 is the Froude number after the jump. Okay, as if you remember the FR equation, Vy root over Gy for rectangular channel. Okay, so the Y is inversely proportional to FR. So before jump, your Y value is small, so FR is greater than 1. Okay, and after jump, your FR is, so after jump your Y value is higher or it increases, so that is why your FR value reaches to 1. Okay, so you should remember this to expression. Okay, it is very important for your competitive exam. Okay, so this is your the relation between y1 and y2, that is your depth of flow before the jump and after the jump. So do you have any doubts regarding this? Or you can do one thing, you go through this, you find any confusion, anything that you should think that we should discuss, then we can discuss in the next class, no issue. Okay, first you go through this derivation and see if you find any problem, you just let me know and we can discuss in the next class. Okay, so we are going to end our class here. Okay, we will continue in the next class about the numericals. We have numericals related to hydraulic jump which you are going to solve in the next class.